Hey guys, this is Mr. Montgomery here. I just wanted to show you a couple of examples before our test to make sure we're ready. So first we're going to start off with multiplying exponents. Here, on our first problem, we have 2 to the power of 3 and 2 to the power of 7. So when we multiply exponents, are multiplying exponents, then we have to add. Remember, every time we multiply, we're going to add. So I'll set this up in a way where it looks better to me. I'll go ahead and write my 2 because that stays the same. It's our base. And I'll add our exponents. So 3 plus 7 is 10. So I'll have 2 to the 10th power. The next one, we have a negative in here. So this problem down here gets a little more tricky. We're still going to add, even though we have our negative. So I'll keep my base the same, because my base does not change. Now I have 3 plus negative 2, because our exponent here is negative. So when I do that, for my base stays the same. 3 plus negative 2 gives us 1. So my answer is 2 to the first power, or 2. Alright. Now, before we go on to division, I wanted to show you guys some equivalents. Alright, so what's another way I can write 5? Well, another way to write 5 is just 5 to the first power. I know this because if I look at 5 squared, expanded, it's 5 times 5. If I look at 5 cubed, expanded, it's 5 times 5 times 5. So that means 5 to the first power would just equal 5. If I write that other way, 5 always equals 5 to the first power. And that stands true for any number. 10 always equals 10 to the first power. And you guys can try it if you would like to see it. You can do 10 squared, 10 times 10. 10 to the first power is just 10 if you would like. All right, so knowing that, how can I rewrite 3 in a different way? Well, I can put 10 to the first power. Now, how would I rewrite 10 to the negative, or 3 to the negative first power? I don't like negatives personally, so I would like to get rid of this negative. The only way to get rid of the negative is to put the 3 under the fraction. So you put 1 above it, and you bring your 3 under the fraction, so you flip it, and it becomes positive. Now, that stands true for any number as well. Any number I have to a negative power. So if I have 5 to the negative first, that is the same thing as 1 over 5 to the first. And this doesn't only work with one of the exponents, it works with any exponent. So if I have 5 to the negative second, that equals 1 over 5 squared, which is also 1 over 25. So those are some ways we can rewrite numbers. I like to rewrite numbers so the equation looks good. If the equation looks good, I know I can solve it. So let's try to put this into practice. All right, guys. So using what we just learned, how can I rewrite 7 squared over 7 to the first power? Well, first, let me split them up so I can see them better. Times 1 over 7 to the first power. Okay, so let's rewrite both of these. Well, my 7 squared is still 7 squared. I like that how it is. That looks fine. There's no negatives in there. My 1 over 7 to the first power, I can rewrite that one as 7 to the negative first. now we have multiplication, and we know it's multiplication, we just add. So I can add that as 2 plus -1. And that would equal 7 to the first power. Now, if we use that same logic, we can, actually guys, we can also do this problem in a different way. We can expand out the problem. This is one way of doing it. Another way would be expanding out. So our 7 squared would be 7 times 7 over 7 to the first power, of course. So we cancel out this division, and that gives us 7 as an answer. Our 7 to the first power. Remember, these two are equal. All right. Now let's try a problem a little more complex. Now remember, guys, this is just for if you feel like you still need help. You can, if you understand it, you can stop the video at any time. But I'm going to keep going for anyone who needs extra help for the test. All right. So we have 3 times x to the 9th over 3 to the 8th times x to the 10th. Let's work this out. Now, problems that are complicated like this, I like to separate. So I think of them separately. I like to think of them by the basis. So we have 3. Okay, what's my 3 is just like saying 3 to the first power, because that's equal, over 3 to the 8th power. Now, at the bottom of the fraction, I have to rewrite this some way so it can be better, because I don't know how to cancel these out, or I don't know how I could do this like this. So let me rewrite it. Since it's down there, 3 to the 8th, I could rearrange it so it looks better for me. So I have 3 to the first over 1, because make anything over 1, over 3 to the 8th, or times 3 to the 8th. Now that I see that, 1 over 3 to the 8th, well, I know that is the same thing as 1 over 3 to the 8th is the same thing as 3 to the negative 8. Those are equal. So if I rewrite my problem, I have 3 to the first times 3 to the negative 8. And now I'm just multiplying. And we know when we multiply, we add straight across our exponents. So I have 3 first plus. I'm going to write that better so you can see it, because my handwriting is pretty sloppy on a smartboard. So we would just add our exponents. So we have 3 negative 7. Because 1 plus negative 8 would be the negative 7, which is the same thing as 1 over 3 to the 7. Now that's half our problem. So this half would equal 3 to the negative 7. But we still have to do our other half. So I'm going to rewrite my x's so they look good for me, because I don't like the way that looks right now. I don't like my x to the 9th over x to the 10th. So I'm going to split those up as well. X to the 9th over 1 times 1 over x to the 10th. Now that I split them up, I can see that 1 over 10 is equivalent, so 1 over 10, or x to the 10th, is equivalent to x to the negative 10. And if I write these together, what I know is equivalent. So my x to the 9th times x to the negative 10th. I know I'm adding now, so I have x to the 9th plus negative 10. So that gives us x to the negative first power. Now, since I have that side of the equation figured out as well, I'm going to go ahead and add that to our equation again. So I have 3 to the negative 7th power times x to the first power. Well, if I use what I know, we're multiplying, so that means we're adding our exponents. 3 to the negative 7 plus negative, oh, I'm sorry guys, I told you the wrong thing. Our bases are different. See, our bases are different, so that is our problem. We cannot add exponents when our bases are different. But there we go, guys, in case you need extra help. And good luck on your test tomorrow. I'm sure you do great.